Hello everyone. In experiment 4 we have 3 lab tasks. First one is construct a 422 encoder with default priority. Default priority is the same as this priority encoder. So default means the less significant bit will have less priority and most significant bit will have the most priority. And the next task is construct a 2 to 4 decoder. So we already designed this one in another video. And the third one is implement the following function using 3 to 8 decoder. So here is our function. So this is in min term. So in these cases the output will be 1. So we have to implement that one in the circuit. So for the lab task 1, here is our design. So let's go to its child sheet, and you can see this is our priority encoder circuit, what we have designed in our lectures video. So I have used to input OR gate, to input NAND gate, AND gate, sorry, and this is the 3 input OR gate, and the circuit is similar to our priority encoder circuit. And we exit, and if we simulate this one, so let's simulate this one, and here is our priority encoder truth table. So whenever as there is no input, so there is no output. Okay, so if one of the input is high, so Z will go high, so we will see that. So first of all, let's check with W0. So if W0 is 1, okay, so we can see that Z is 1 and Y1 and Y0 both are 0. So Y1 and Y0 both are 0. So it's working. And the next one is W1. So in W1 you can see Y0 is 1. So here is Y0 is 1. And for W3, let's check with W3. So Y1 is 1. So it's working. And last one is 1. So both are 1. And whether it's working as also a priority encoder, let's check that one. So first let's give high in W1. So W1 is high, so we see Y0 is 1 and Y1 is 0. It is okay. Now we will make W2 high. So you can see in W2, whenever W2 is high, so our output should Y1 and Y1 1 and Y0 is 0. So it's working actually. So it is not taking consider of this input now. So whether it's changing or not, it has no impact on the output. So it's actually working as a priority encoder. So this is actually the simulation of lab task 1. Now we will go to the lab task 2. So lab task 2 is 2 to 4 decoder. So here is the circuit, and this is our another sub circuit. So if you go to its child sheet, you can see the main circuit. So here I just use 3 input AND gate, NOT gate. Okay, so let's simulate this one. So in this case we have an enable pin and our 2 input pin, and these are the output. So if you turn on the simulation, so you can see as enable is 0, so there is no output. So 0, no output. So if we make it high, you can see if W1 and W0 both are 0, then we will get output high at Y0. So we are getting high at Y0. And for the next one, we are getting at Y1, and for 10 we are getting high at Y2, 10 Y2, and last is the 1 is y3. So it's perfectly working as our truth table. So this is our the 2 to 4 decoder system. And for the last part, if you see the function over here, you can find that in only 0 to 3 7 cases the output will be high, and for 1 and 4 cases it will be taken as a don't care. So if you see the circuit over here, you'll find that so here is y0. So y0 goes to our OR gate. So either of these 4 output is high, so it's I connected it with the OR gates. So if one of these 4 data is high, we'll get some output at the final end. So this is our F actually. So actually you can use 4 input OR gate. I just cascade this thing and make it so this and these two are cascaded in this thing. So these are OR and this OR went to this OR gate. And also you can also take it as a don't care condition. So in your K-map, if you take a consider this as a 1, so you have to take this as a 1. So for 1 and 4, so this is 1 and 4, you can see 1 and 4 also is connected with the OR gate. So this also going to this OR gate. So actually for 6, either of 6 output if goes high, our function will show you a high data. So if you see the circuit, so already in here you can see that we have to use 74138 decoder, 3 to 8 decoder. So this is the 74LS138 decoder. In this pin, this C is the MSB, and here also C is MSB and A is LSB. So A is LSB, so we connect, this is C, this is B, and this is A. And for this IC, you have to make E2 and E3. So here there are actually 3 enable pin. So E2 and E3 should be grounded, and E1 need to be high, or you have to power it high, positive 5. So in this case I make it high with a logic probe, and the output is connected with a logic probe, and the input is connected with a logic toggle. And another thing is to note that all the output are active low. So you can see a dot in the output. So if the output is in our truth table is 1, actually it will show 0. That's why we use an inverter to make it active high. Okay, now let's check the function and the circuit. So we should get 0, we should get 1 when the all the input are 0. So M0 case. So if we turn on the simulation, and you can see that our output is 1. So I make it enable, and if I make it 0, so output will not show a valid data. So I make it high, and all the input are 0, so we are getting 1. So this condition is fulfilled. And next one is 2. So that means we have to give binary 2 over here to see the output high. So first make it 1. So you see for 1 our don't care condition, that's why we are getting 1. And if we make it 2, so 2 is this one, 1 0. So for 2 we are getting high. Okay, that is fine. The next one is 3. So make it 3. 3 is high. Okay, fine. Then next one is 4. So make it 4. So 4 is high, fine. And then 5 should give 0, right? So let's make it 5. So the output is 0. So it is working perfectly. And the next one is 6. For 6 the output is 0, and for 7, okay, so the output is high. So our circuit actually follows the function. So the circuit is perfectly working. So this is actually all the simulation part of our lab task, and now you have to do these two circuit design in your lab report. The first one is construct a priority encoder which implements the encoding of 0, 3, 1, 2 with descending priority. So 0 has the highest priority and 2 has the lowest priority. So in our previous encoder we see that 0, 0 has the lowest priority, and 3, which is 1, 1, has the highest priority. In this case, so 0, 0 will be the highest priority, then 3, that means 1, 1. 1, 1 will have the second highest priority, then 1, so 0, 1. So 0, 1 will have the next priority, and 2 has the lowest priority. 2 will have the lowest priority. So this is actually your output encoding with the highest priority to lowest priority, and considering this thing you have to design the circuit priority encoder actually. And the next one is draw a circuit diagram with encoder and decoder that will output the ones complement. So with the 3-bit number, so there will be 3 input, so as a 3-bit number, and there will be a 3 output, and you have to use one encoder and a decoder. So yes, if you give an input of 101, so the ones complement of 101 is 010, sorry, 0. So just the opposite or inverted data. So you have to design this system that will take input of a 3-bit number and give a output of a ones complement of the input data. So that's all from experiment 4. Thank you all.